All right, your review for the Unit 4 quiz, it says, but it's going to be our test. All right, so the first one, again, it's just calculator one. All right, you got to know where the factorial button is in the calculator you're using. So it's 8. Then if I go under math, under this one, it's probability, and there's our factorial. So 8 factorial, so 40,320. And then 3 factorial, 5 factorial. Again, 3. So 3 factorial, 5 factorial, 720. The next one's the P, so 6 P. For permutations, 3. And again, we do permutations when order doesn't matter. So that's 120. And then we got 7 P4. That's 840. And then we got 5. And now it's C this time. So combinations, this is when order doesn't matter. 2. And that's 10. And then 9. 6. And we got 84. Alright, so those are combinations and permutations ones. Alright, this one, how many different ways can you choose 6 starting players with a unique position? Unique position, that tells you you're going to use P because order matters. Alright, for my volleyball team that has 9 people, so this one is 9P6. And again, let's put it in the calculator, 9 P6, 60,480. All right, different ways. All right, and then the next one, suppose you choose 5 equally useful articles. All right, related to your paper on in how many ways can you choose 2 articles to read. Since they're equally useful, they're all the same weight, so it doesn't matter the order. All right, so this one's going to be combinations, so it's 5C2. All right, and then we just put that in. I already had it in. 5C2 was 10. All right, and you didn't have to do that one. All right, so this next one, we want to find the probability of red. So there's 7 red ones out of 28 total. So you can either write it as 1/4 or 25%. Again, it has to be reduced. Probability of blue is 12 out of 28. That reduces to 3/7. So you can either give 3/7, which is approximately 43%. All right. And then not blue. Well, 16 of them are not blue out of 28, which reduces to 4/7 or 57% approximately. Again, and make sure you round them correctly. All right. And the probability of red or white is 4 out of 7. Because that was the same as probability of not blue. So again, 57%. All right. All right. 11. A month is selected at random, and a number is selected from 1 to 10 at random. These are independent. One has nothing to do with the other. All right. A number is selected from a hat at random. A second number is selected without replacing the first. All right. So this one is dependent. All right, 13, the probability of M and N, and these are independent events. So this is equal to the probability of M times the probability of N. So first one would be 2/7 times 3/4. So we get 6 out of 28, which reduces to 3 out of 14. So you can give that as your answer, or 21%. All right. So either one of these two is fine. All right. All right. And then same thing here. We're going to multiply. So 5/8 times 3/8 gives us 15 out of 64, which does not reduce. So you can give that as your answer, or you can give 23%. Either one of those. All right. 2 fair dice are rolled. State whether the events are mutually exclusive. Explain your reasoning. All right. The sum of the numbers is even, and the sum is more than 4. So this one is not mutually exclusive. Again, we're rolling 2 dice. And I would say you could roll a sum of 6. 6 is an even number, and it's more than 4. So you can do it in one roll. You can do this, so it's not mutually exclusive. All right. The numbers are both odd. The sum is odd. This is mutually exclusive. The sum of 2 odd numbers is even. All right. So it's mutually exclusive because the sum of 2 odd numbers is always going to be even. So this says the numbers are both odd, and this one says the sum is odd. Well, that can't happen if they're both odd. All right. So that's that. All right. Next, we move on to this part. All right. And this is our OR, probability of G, and they're mutually exclusive. So all we have to do is the probability of G plus the probability of H. So for the first one, it's just 2/9 plus 4/9, which gives us 6/9, which reduces to 2/3. So you can give either 2/3 or you can give 67%. Remember, round it properly. All right. The next one, we have 2/7 plus 1/4. Here we need a common denominator. The common denominator would be 28. So we'd have to multiply by 4. So multiply the top by 4. The bottom, 28. So multiply by 7. So that gives us 15 out of 28. So again, you can either put that as your answer, or you can put 54%. All right, fair dice, find each probability. 4 or prime. Well, the probability that's a 4 is 1 out of 6. And again, this is the OR one, so we're adding. So plus probability that's prime, which would be 3 out of 6. And that would give us 4 out of 6, which again is 2/3 or 67%. All right. Probability it's even or less than 3. Now these aren't mutually exclusive, so we have to do the probability that it's even plus the probability less than 3 minus the probability even and less than 3. All right. So the probability it's even, we would have you're only rolling 1 dice, so 2, 4, and 6, so 3 out of 6, plus probability it's less than 3, that would be a 2 or a 1, so that would be 2 out of 6, minus the probability it's even and less than 1, 1 out of 6, so 3, so it gives us 5/6 minus 1/6, which would be 4/6, which again would be 2/3, so 2/3 or 67%. All right. Our whole class has been invited to go, our whole class of 20 students have been invited to go to The Price is Right. we're going to go when there are only 80 people in the audience. That's 80 total, including our class. What's the theoretical probability that 4 of our students from our class are picked as contestants out of 12 possible spots? All right, so the first thing we got to do is get the 4 from our class. All right, so our class has 20, and it doesn't matter what order, so it's going to be C, 4. All right, so that's the 4 from our class. Other contestants that get picked, well, there was 80 total, so 60 of them weren't in our class, so it's going to be 60, C, and we 4 from our class, but there's 12 that are possible, so we still need 8 more from the other part of the audience, and then that's going to be over all of them in the audience, so that's anybody in the audience that gets 12 of them. They pick 12 of them. All right, so it looks like this. All right, and again, you're going to do this all in the calculator. This is approximately equal to 0.2057628. So you should get that when you put that in the calculator. Make sure that you know how to do it. All right, and you can either write this as 21%, approximately 21%, or 20.6%. Just make sure you round it correctly. All right, and then our geometrical probability one. All right, so we got a large rectangle. It's 2 feet by 4 feet. What's the probability to land in either of 2 green circles that have a diameter of 4 inches? All right, so we got a big rectangle. That's 2 feet by 4 feet. But again, we got to get our units to be the same. We got 1 in feet and 1 in inches. So I'm going to convert this to inches. So that would be 24 inches. And this would be 48 inches. All right, and then we got 2 green circles. All right, and they have a diameter of 4, so that means the radius is 2. All right, diameter 4, radius of 2, because we need the radius for ours. So we got to do the area of circles divided by area of rectangle. All right, so now the circles, we have 2 of them, so it's going to be 2 times pi r squared. The radius is 2, so it's going to be 2 squared. Whoops. All right, so 2 times pi r squared. That gives us the radius of, or the area of the 2 circles. And then it's divided by the area of the rectangle, which would be 24 times 48. All right, putting that in the calculator, that's going to give us 0.0218. So it's approximately 2% because this says round it to the nearest whole percent. All right, so approximately 2%. All right, and then suppose you choose a letter random from standard. What's the probability that letter chosen at random? So you pull a letter out of the alphabet, and what's the probability that it's either in word standard or deviation? So they are not mutually exclusive. They have letters in common. So we have to do the probability that it's in standard, which is 6 different letters out of 26 in the alphabet, plus the probability that it's in deviation, and that's going to be 8 different letters out of 26, minus the probability that it's in both. All right, and the probability, the ones they have in common, there's 4 out of 26. All right, so when we do this, we get 10 out of 26, which reduces to 5 out of 13, or approximately 38%. All right, so again, either one of those answers is fine. All right, now we're not replacing this in this problem, so we've got a jar that contains 16 blue and 9 red marbles, so that's 25 total. Suppose you choose a marble at random and do not replace it, then you choose a second marble. Find the probability of each. So we want the probability that we select the blue marble first, which would be 16 out of 25, times, then we select a red marble. So now there's 9 red marbles, but we took one away, so now there's only 24 total. All right, and then we just multiply that out, gives us 144 out of 600, which reduces to 6 out of 25, or 24%. All right, and then the next one, you select a red marble. Well, we have 9 red ones out of 25, times, now we select another red one. So now we already pulled one red one out, so now we only have 8 left, and we pulled a marble out, so we only have 24. So we multiply this out, we get 72 out of 600, which is 3 out of 25, or 12%. So again, either one of those answers is fine. All right, and then this last one should be easy. 55% of the people in school are under 16, 10% are over 40. What's the probability the person chosen is under 16 or over 40? So we just have to do the probability under 16 plus the probability over 40. All right, so that's going to be 0.55 plus 0.10, which gives us 0.65, which is 65%. All right, and that's what your quiz looks like.